In this video, I'll walk through the proof of result 3.19 from the text, which is that if R and S are rational numbers, then their sum, R plus S, is rational. Notice this could also be stated, the sum of two rational numbers is rational. That's another way to state this, and so you should be able to go between statements like this and identify, oh, R and S are rational numbers then, and then show that R plus S is rational. So this is what I want to show. But first, just like with even and odd in numbers, we had to first state a definition of even and odd. Now we've actually already encountered the definition of a rational number, but I'll state it again here. If R is a rational number, then R is equal to a ratio of two integers. That is, R equals A over B, where A and B are integers, and B is not equal, where A and B are integers, and B is not equal to 0. So that's what it means to be a rational number. So that is, if I know a number is rational, that means I can write it as A over B, where A and B are integers, and B is not equal to 0. And if I want to prove that a number is rational, then I need to find A and B, show that they're both integers, and that the denominator B is not equal to 0. So that's the idea. I'm going to need to do both things here. I'm going to start with assumptions that things are rational, so I'll be able to write them like this. And then I'm going to need to show that something else is rational, so I'll need to write it like this, produce two integers. So that's definition of rational. And then another property that's going to be helpful, another axiom, again, we're not going to prove this. We're going to accept it as fact. And this is called the zero product property of real numbers. And that is that the product of two real numbers is not 0 if and only if both numbers are not 0. Stated a different way using the contrapositive, the product of two real numbers is 0 if and only if one of these numbers is 0. At least one of these numbers. At least one of these numbers is 0. So I'm going to use this along the way. In particular, I'm going to need to show that my denominator is not equal to 0 to conclude that R plus S is rational. And my denominator is actually going to look like a product of two integers. And so I'm going to need to show that that's not equal to 0. I'm going to need to use this zero product property. So let's talk strategy. So my assumption is that R and S are rational. So what does this mean? I'm going to use the definition. R is equal to A over B, where A and B are integers, and B is not equal to 0. And I know that S is rational. So I'll be able to write it as, and I don't want to use the same variables A and B, right? That imposes a connection between R and S. That means S depends on R, but here it doesn't, right? I just want to assume any two rational numbers, their sum is also rational. I don't want to impose any sort of connection between R and S. So I don't want to reuse A and B. I need to come up with two other integers. So let's call them C and D. C and D are integers, and D is not equal to 0. Again, I couldn't write this as A over B. If I wrote S equals A over B, that would imply that S is equal to R. And that's an assumption that we're not making. We don't want to assume that R is equal to S. And so we need multiple variables here. So that's something to watch out for. So I'm going to need to show that R plus S can be written as a ratio of two integers is rational. So write as a ratio of two integers and show that, one, that they're really integers and that the denominator is not equal to 0 with non-zero denominator. Okay. Do you have an idea of how we're going to do this? Think about it for a second. I'm given R and S. I can write them like this. and then I can take their sum, right? I can look at R plus S, and so I can add up A over B plus C over D. Right? R plus S is going to look like A over B plus C over D. And I'm going to want to write this as a ratio of two integers. So how can I write this sum of two fractions as just a single fraction? Well, I'm going to combine, I'm going to find a common denominator and combine these. So this is my strategy, find common denominator. All right, let's prove this. Since R and S are rational, R is equal to A over B, where A and B are integers, and B is not equal to 0. And I can do the same for S, and S is equal to C over D, where C and D are integers, and D is not equal to 0. Now I'll take their sum. Then R plus S is equal to A over B plus C over D. And one easy way to find a common denominator here is to just take the product of the two denominators. So I'll multiply this first fraction by D over D and the second fraction by B over B and combine them. So this is equal to AD over BD plus CB over BD, which then I can, now they have common denominators, so this is AD plus CB over BD. So this is great, right? I've now expressed R plus S as this ratio, and now I just need to conclude that the top, the numerator is an integer, the denominator is an integer, and the denominator is not equal to 0. So I'll say since A, B, C, and D are all integers, AD plus BC is an integer. That's that property of integers that we looked at. And also BD is an integer. That product is an integer. And BD is an integer. And I also need to conclude that the denominator is not equal to 0. But I know, right, by assumption, B is not equal to 0 and D is not equal to 0. So this is where the zero product property comes in. Product of two real numbers is 0 if and only if both numbers are non-zero. So both B and D are non-zero, so I can conclude that their product is non-zero. Since B is not equal to 0, and D is not equal to 0, BD is not equal to 0. So that's the zero product property. And now I've verified I have a ratio of two integers where the bottom is not equal to 0. So R plus S is rational. And it's proved. Pretty cool, right? So while we took for granted that the sum of two integers is also an integer, and that seems fair to just take that as fact, I don't think it's quite as fair to just assume that the sum of two rational numbers are also rational, right? There's actually something that needs to be shown there. It's not trivial, as we would say, right? I mean, this whole proof that we just went through demonstrates that it's not trivial, that there is actually some work that needs to be done to demonstrate that their sum is rational. And we've done that work now. So now we can use the fact that, we can use this now in other proofs. We know that if I have two rational numbers, then their sum also has to be rational. We'll use this fact, this result that we've proven now later on in the section, in the chapter, I mean. Okay, that's it for this video. And that's it for this week of videos. So I'll see you next time.